Okay, our next topic, nth roots, coming from section 7.6. You can see we have quite a few objectives today, learning goals. Might take a couple days, but we'll get to them. We want to evaluate a power of b to the n when we have a positive exponent, and that n value is rational, which means it'll be a fractional look. We want to simplify anything that has the form of 1 over n as an exponent. Obviously, then solve equations that have these exponents of fraction looks. Recognize properties that they have when we see their graphs, etc. And then solve some real-world problems. So it's loaded, so let's get started. If we're to warm up on some of these powers, positive exponent powers that we've been using, and we say don't use a calculator, then we want to be able to know in our mind, off the top of our head, we want to be good enough to be able to say, what is this? Now, most of you know that we've been doing powers and roots, so we have powers here on number 1. If x squared equals 144, you should be able to say x equals and give me my values. But remember, since it is an equation, we're going to get that plus minus look. So x equals, and we would say plus or minus 12. Going to number 2, the change in your brain has to be what single number, so cube root of both sides, what single number multiplies by itself to give me a positive 8. Now here we don't want necessarily to be talking about the plus minus immediately because you got to think. If I had, in this case, a 2, 2 times 2 times 2 is 8. But if I had a negative 2, negative 2 times negative 2 times negative 2 does not give me that positive 8. So in this case, you're only going to get that one solution, x equals 2. Number 3, we're back to fourth roots. Fourth root is even. Even means I can have plus minus. So x equals plus or minus. Now keep in mind, we know the square root of 81 is 9. So the fourth root of 81 should be 3. Do the math. 3 times 3 is 9. Another set of 3 times 3 would be 4 3s, which is 81. And so we get plus or minus 3 would work for that one. Number 4, back to a cube root. So x equals, what is that one number that multiplies by itself to give me 64? 4 times 4 is 16, and times 4 more. So our cube root of 64 is 4. Next, we get a fourth root of 25. So you start saying, what number multiplies by itself 4 times to give me 25? We already did the 2, and we said 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 is too small. So we try a 3. 3 times 3 is 9, times 3 is 27. Ooh, we've only multiplied 3 3s, and we're already over. So this is one of those where you're going to say that it is not a whole number. It's not a perfect power. So if we did the fourth root on both sides, we would get our x equals plus or minus, again, because it's even. And we would have to say the fourth root, put your little 4 in that slot, the fourth root of 25. So if you actually wanted to get an estimate of what that is, you could use your calculator to do that. But if not, there is your exact answer. And number 6, we got a square root. So again, we're changing our brain's thought process the whole time. Square, we're looking at x equals plus or minus. And now we have a fraction. So some people say, oh, I don't like fractions. But don't look at it as a fraction. Look at it as a numerator and denominator that are both perfect square numbers. So square root of 25 is 5. Square root of 64 is 8. The fraction, 5/8 is reduced already, so we should be good to go. So keep in mind you have to have a working knowledge of your perfect square numbers, perfect cube numbers that are fairly small. You don't have to know them as far as you do the squares. Perfect fourth root numbers, doing those in your head is going to make your life a lot easier as we move forward. All right, so now looking at these statements. X is a square root of t when x squared equals t. So we would say in words, if we were looking at this first statement, 4 is the square root of 16 in this statement. The next one, it's a cube root. Same exact setup. So 3 is the cube root of 27. X is the fourth root, mean anything to a fourth power. So 2 is the fourth root of 16. 2 is that one number that multiplies by itself 4 times to give you 16. So we should be able to do that with any combination. Say x is the nth root of t when it's taken in this form. Okay? So we're not just going to stay in our comfort zone and work with square roots. We're going to branch out. Cube roots, fourth roots, fifth roots, sixth roots. All of the above will be used. So knowing that, remember a root sign was used for all of them, but to denote your different signs. So right here we have a root symbol, nothing underneath, but now here going down, the our square root of 49 would give us 7 because it's asking what is the positive. You don't do the plus minus. This is what is the positive square root of 121. You would say 11. There's a cube root symbol. Then what's the cube root of 125? What is that one number that multiplies by itself 3 times to give you 125? And it's 5. What is that one number that multiplies by itself 3 times to give you 1,000? Well, 10. There's the fourth root symbol. Same thing as we keep going. So what is the fourth root of 16? 2. Fourth root of 81. What is that one number that multiplies by itself 4 times to give you 81? And we know it's 3. So whatever combination we give you, remember that the little number on the root sign tells you how many factors of your answer you need to get to your original starting number that was underneath. Okay, that's the thinking, that's the mental math you need to perform. So it does rely on your times tables and knowing them fairly well. A calculator is not just going to spit out your answers for you. Now, next, knowing your perfect numbers definitely helps. So if we said your perfect square numbers, so when you do n squared, you go right up the list. 1 squared, 2 squared, 3 squared, 4 squared. You're getting these perfect square numbers. If we do n cubed with any set of numbers, and we're doing it in order, then we would get 1 cubed, 2 cubed is 8, 3 cubed, 27, 4 cubed, 64, right on up the line. And notice after 5 times that we're already in triple digits on the cubes. The next one we were saying what number multiplies by itself 4 times, in other words n to the 4th. So 1 to the 4th, 1, 2 to the 4th, 16, 3 to the 4th, 81, 4 to the 4th. Look at that. After 4 numbers, you're into triple digits. And it's only going to keep getting worse here because you're going up by powers of that factor. The next one is the fifth. 1 to the 5th is 1, 2 to the 5th, 32, 3 to the 5th, 243. So these are all combinations of perfect square, cube, 4th power, 5th power numbers. Now, what you probably haven't seen is that anytime we do write that root, and we're talking about an integer here, which is what we said we needed when we had a square root, a cube root. You know, these are integers that are sitting there. They're not fractions or anything. We can write that in a different way. This is called radical look. Okay, so here's the radical, because that's what that symbol is called, the root. And then the new look is what if I just take that base number of x and take it to the power of 1 over that number. So a square root, let's just do the square root of x would be the same as x to the 1/2 power. The fifth root of x would be equal to x to the 1/5 power. Now what you have to remember with your calculator is that when you go and put this into your calculator, you want to be careful. Some calculators allow you to put it in just as is because it does it as a raised up exponent, but others do not. Everything's on the same line. So you want to make sure that that 1/2, 1/5, whatever it is taken as a fraction. You must enter it in parentheses. Some people say, could I enter the decimal form? Yeah. So if you wanted to go x to the 0.5 power, x to the 0.2 power, you could do that. But really you only can do that when your fraction terminates. All right, so this is just another way of writing it. This would be called the exponential form because they look like exponents. So we have the radical form over here that has more of your square root symbol look. And then we have the exponent form over here. Both of them are acceptable, and you should be able to move back and forth interchangeably as we move ahead. So in this section, we're saying, well, what if we do look at them as graphs? And we have y equals x to the n. Now, you're going to say, well, I don't have an example. Well, let's put an example for each of these down. What if we said, for this one, I want you to look at 7 equals x to the 4th power. Anything that's even we know would graph into a parabola. Over here, what if we said the same thing, 7 equals, and let's just make it x to the 3rd, an odd power, other than 1, because we know 1 would make it a line. So an odd power bigger than 1. Even power, 2, 4, 6, any of them. So we know by default that this is really two equations. This is y equals x to the 4th, and this is really y equals 7. And you have graphed both of those before. This one would be y equals x to the 3rd, and y equals 7. And by process of substitution, you then get your equation 7 equals x to the 4th, or 7 equals x to the 3rd. So what it really means is if you were going to your calculator, you would graph your y equals x to the 4th, which you can see I already have done. We'd have a nice parabola look. And then we'd have to do y equals 7. But what you have to remember is that y equals 7 is nothing more than a horizontal line. So let's get to 5, let's get to 6, let's get to 7, place our horizontal line. What's going to happen when we place that horizontal line on an even, so a parabola, situation, and it doesn't matter if my y value is positive. All of these positive values, look at them. What's happening with that parabola? Knowing that parabola continues upward forever, and you should be saying that it's intersecting twice. Our horizontal line is hitting our parabola in 2 spots. Now, as soon as I go right here, as soon as I go right here to the origin, now it's only hitting once. And as soon as I go to any y value that's negative, what do we have? So those are observations that you need to make in this symbol. But right now, if we go back and just identify what happens when our exponent was even and our y value was positive, we're going to get 2 solutions. As soon as y was 0, we only got 1 solution. And as soon as y was a negative value, we got no solutions. Okay, let's bring this over to our odd situation. So if we keep, and this time it was a 7, so if we draw our horizontal line at 7 and have our odd powered graph showing, which you can see I have here, this line and our S shape that represented our x to the 3rd equation is only intersected in 1 spot. And if you look at that, it doesn't matter what that positive y value is, it is only hitting it in 1 place. The intersection point is 1 spot. Even if I go to 0, it's only 1 spot. Even if I come down to all the negatives. So we have quite a difference on these two. And we're expecting you to remember this. So if you go back and say, get this out of the way, if we say if we're given any equation in the form y equals x to the n, The first thing you need to say is, what's your exponent? If it's even, I've got this kind of graph. If it's odd, I've got this kind of graph. All right? The characteristics we want you to say for a positive is if a positive real number has two real roots, a negative real has no real roots. So in other words, we said if you get down there into a negative, you're not going to get anything, any intersections. Okay, so that means it has some solutions, some roots. If it's 0, it has 1. Okay, we did not include that in the little list. Over here in the odd situation, every real number, no matter where I put it, had exactly 1. So you should be able to show that with a graph. You should be able to know that with a graph quite quickly. So let's go and simplify now with our different forms. And remember, if you don't like the exponential form, you could rewrite it in radical form. But this is basically saying the cube root of 27. So again, if this works, this form, radical form works better for your brain, that's what you need to do. And the cube root of 27 is 3. Go to number 2. 0.25, be careful. You might even want to change that to 1/4. And then the 1/2 power means the square root of that. So what is the square root of 1/4? You should know the square root of 1/4 is the fraction 1/2. 81 to the 1/4. So again, if you like roots, you'd be doing this. But they're the exact same process. One's just radical form, one's exponential form. So this is saying, what is the 4th root of 81? What is that one number that multiplies by itself 4 times to give you 81? And you're saying it's 3. We got another fraction over here, and it's a 4th root. So be careful. Start thinking of your 4th roots numbers. What is that one number that multiplies by itself 4 times to give me 16? Most of you know that's 2. What is that one number that multiplies by itself 4 times to give me 625? That one's a little bigger. You may need to use your calculator, but I think you have a good hunch. We already had done 5 times 5 is 25, times 5 is 125. 125 times 5 does give you 625. Check, is your fraction in lowest term? 2/5 is, we're good. Now, when you get to one that's not a perfect cube, like we have here, then you have no choice but to read directions and see what they're looking for. When I say read directions, do they say write as an exact value? If they say write as an exact value, you are done. If this is not a perfect cube number, 115 is not a perfect cube number, then you can't break that down. However, if it is, the direction round to the nearest, find the value of your number and round to the nearest. You need to make sure that you, when attempting this one, that you're going to your calculator and you are putting your exponent in as a fraction. So 115 to the power of 1 divided by 3. So it's the cube root. And then getting your decimal, and in this case the decimal is a 4.862944-ish, and if it said round to the nearest hundredth, we would be looking at a 4.86-ish number. So watch directions on this one and see what they're asking for. Now if it says find all real solutions, like this one does, and you're looking at a cube root, we know we need to take the cube root of both sides, and we have a negative number here, so make sure you're thinking about that negative number in its cube root form. So when you punch this one in, you would be putting 343, and then to the power of 1 divided by 3. And you're looking for what one number multiplies by itself to give you a negative 343. And that answer is negative 7. And you're saying, well, why does it come out negative? Because remember, a negative times a negative times a negative will still give you a negative. Where in an odd power, you can get positive answers on some of them, negative answers on some of it. It all just hinges on what are you evaluating to start with. In this case, we have a negative. We're going to get a negative result. So the practice today will be more about radical form to exponential form, working on your powers, working on getting to know your perfect powers, perfect cubes, perfect fourth powered numbers, so you can get better at them. Watch directions, because I do know some of them will ask you to round and some of them will say, keep me exact. All right? Bring any other questions you might have to class with you.